What we're going to do today is we're actually going to do some log graphs. I hope you did a little better in that second homework. Now, some of you are using your calculators and giving decimal point answers for things. If I do a whole lesson and I never use a calculator, that means you shouldn't be using a calculator either. Again, your final exam is going to be written, so you don't need a calculator at all. So unless you see me using a calculator in the lesson, you should be doing them the same way as me, solving exactly. Same deal here. We're going to be sketching logs. I'm going to do this whole thing without a calculator. So try to stick with me on this. This I think you're going to like, but do it without a calculator. So what I want to do, number one, now, highly recommend, if you haven't done so already, I put a PDF of this up on Google Classroom. Your best bet is to stop me now, print that out so that you can do the exact same notes as me on the same sheet of paper. If not, write down the equations. I'll read them to you so that you can see them. But you want to print out the graphing log equations worksheet so that you can follow along. And again, if not, just write down the equations and kind of, if you have graph paper at home, you could do it on your own graph paper. All right, so I'm going to give you a second to do that. Okay, so either you printed it out or you're going to follow me on paper, but the first thing we're going to do for number one, it says, in case it doesn't look clear, on the same set of axes, sketch f of x equals 2 to the x. So f of x equals 2 to the x, and g of x equals log base 2x. So we're going to graph both of these on the same axes. And what I'm going to do first is f of x equals 2 to the x. Now, we did exponential graphs before everything shut down, and I always recommended doing 3 equations. Now, let me get a piece of scrap here. We talked about how exponential graphs have 2 different kind of looks, right? If I were to graph an exponential function, okay, this is the x-axis, and this is the y-axis. Exponential graphs usually look like that, or this is x and y, like this. Okay, now this is a little recap. All exponential graphs have the same point in common, and that is the point 0, 1. Because everything raised to the 0 power makes 1, right? Now, they both have the same asymptote, right? Notice it's the x-axis, and the asymptote here would be the equation of the x-axis, which is y equals 0. Same deal here. Y equals 0 is the asymptote. Now, this is an increasing function, and this is a decreasing function. How do I know it's an increasing graph versus a decreasing graph? And I'm hoping you remember it's because if it's the base, if the base is greater than 1, it'll be an increasing graph. And if the base is between 0 and 1, it's a decreasing graph. So this is for exponential. Okay? So the first thing we're going to graph here is f of x equals 2 to the x. And because my base is 2, which is greater than 1, this should be an increasing function. And I told you guys, if you get me 3 points, and it could be, I always suggest 1 negative, 0, 1 positive. And it doesn't have to be negative 1, 0, 1. You can do maybe negative 2, 0, 2, just to change it up, right? What's anything to the 0 power? 1, right? It's 2 squared. That would be 4. And 2 to the negative 2 is 1/4. Now, if you know 3 points and the way the curve should look, that's all you need in order to graph successfully. So what I'm going to do here now is actually, this is my blue. Put my x and y axis on here. X, y, right? And I'm going to graph this guy in red. So it's going to be negative 2, 1/4. Right, so this is negative 2. 0 is 1. and 2, which is here. We're up at 4. 1, 2, 3, 4. And this graph looks like this guy. Right? So this is f of x. All right, so basic exponential graph. And again, if you have 3 points, know what kind of curvature it is, you can get a nice graph. All right, now let's do g of x. So g of x now is log base 2 of x. Now, the easiest way to graph logs is to convert it into an exponential function. So g of x, right? Actually, here's my, oh, I don't have it with me. G of x you can think of as y, right? So I'm going to rewrite this as 2 to the y equals x. So that way, when I make my xy chart, this time notice the exponent is the y value. So I'm actually going to do 3 points, but I'm going to do them over here. I'm going to plug -2, 0, and 2 in. So watch, what's anything but the 0 power? 1, right? Plug 2 in for y here. 2 squared is equal to 4, right? And this will be 2 to the -2 equals 1/4. Now notice, look at your x and y tables. See how these flip-flopped, right? That's because exponents and logs are inverses of each other. Because they're inverses of each other, it means the x and y values should have switched, right? We switched the x and the y here. That's exactly how that works. So now watch, I'm going to plug these guys. So at 1/4, I'm going to be at -2. So when x is 1/4, so when x is 1/4, I'm going to be at -2, which is right there. When x is 1, I'm going to put it down at 0. And when x is 4, I have it down at 2. So the log, now if I connect these, looks something like that. Now, log graphs, right, are the inverses of exponential graphs. Now, I don't know if you guys remember, but what reflection means the same thing as an inverse? And that's a reflection over the line y equals x. Watch. If I do 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So if I graph the diagonal line, y equals x. This is y equals x. And this is g of x. Right? Notice they're both reflections over this line, y equals x. That's how it confirms it's an inverse as well. So let's go back to this guy. Right? This is what basic exponential graphs look like. Logs have basic setups as well. So for a log graph, right? Here's x, here's y. A log graph will always hit, now exponential graphs always hit the point 0, 1. But since log graphs are the inverse, they're always going to hit the point 1, 0. And log graphs always look something like that, right? I always say it's like a firework that goes off and dies, right? But these guys also have asymptotes. Now, for an exponential graph, the asymptote is the x-axis. For a log graph, the asymptote is going to be the y-axis. So this is going to be x equals 0. And there you have it. So these are your basics. Let me scan this up. This is a super important paper. Your basic exponent and log graphs. All right, so let's go back to the worksheet and take a look at number 2. Right? The second one, right, in case you can't read it, says h of x equals log base 1/2 x. Okay, so what I'm going to do for this one is the first step with a log graph, I'm going to change it to, if this is h of x is the same thing as y, so I'm going to bend it. Okay, I'm going to pick one negative. Now, Look what I just did out of habit. Look what exponent is, what's in the exponent to y. So you're actually going to do it over here. -2, 0, 2. That happens all the time where you go by habit, but be careful with logs. Logs are backwards. So you're going to do it over here. So I like to do the 0 power. 1/2 to the 0 power is 1. I'm going to do 1/2 to the -2. What does that equal? 4. And 1/2 squared is going to be 1/4. Okay, so now I'm going to set this up. I'm going to draw in my x and y axis. X, y. All right. So when x is 4, I'm going to be at -2. So 1, 2, 3. So here's 4. I'm going to be down at -2. So I'm right there. And x is 1, I'm at 0. Okay? And when x is 1/4, I'm going to be up here at 2. So this guy looks like that. That's what happens when you have a base that's between 0 and 1. So if you notice, right, it's a little flip-flop from this guy, because it's going down instead of up. And my asymptote, let me write it over here, my asymptote is still x equals 0. Okay, now, this is where things are going to start to get interesting. We're going to start shifting everything around. Now, before I deal with the +1 and the -2, what I want to identify here is what is the parent function. The parent function means what would be the meat and potatoes of this with all of the extras. So let me just read what the equation says in case you can't read it. It's p of x equals log base 4 x plus 1 in parentheses minus 2. Right, now this is my parent function. The parent function would be y equals log base 4x. That would be the basic equation without the shifts. So start with that. And we're going to make an XY chart for that first. So, oops. First thing I'm going to do is bend it. So that's 4 to the y equals x. All right, now I'm going to make my XY chart. Actually, I'll just keep using the black. Now, because the y is in the exponent, right? Now I keep using -2, 0, +2, but you could do -3, 0, 3, -1, 0. I always do a -0, +. Right? So now I'm going to plug on in. 4 to the -2 is 1/16. 4 to the 0 is 1. Right? And 4 squared is +16. Now, here's the deal. This is not what we're graphing. This is just what the parent function would look like. We now need to graph this guy. And this is where we're going to bring in our shifts. Now see here, x plus 1. Where would that shift? I'm hoping you're thinking it's going to shift 1 to the left, because you always do the opposite for the x. So check this out, guys. I'm going to go down my x column, and I'm going to subtract the number 1 from each of these. So I'm going to make another XY chart and subtract 1 away from all this. So if I do 1/16 minus 1, it's -15/16, right? Subtract 1 away from him, 1 minus 1 is 0. And 16 minus 1 is 15. All right. Now, this guy, -2, that means the graph's got to move down 2. That would affect the y values, so I'm going to subtract 2 from each of the y's. So it's -4, -2, 0. And this is the equation for what they want us to graph. Now, there's one other thing I want to talk about, and that's the asymptote. Anytime you guys start shifting, it's going to affect the asymptote. Now, for logs, the asymptote for a basic, right? The asymptote for the parent, the asymptote for for the parent would be x equals 0. So the new asymptote, right, would be any shift that happened to the x is also going to affect the asymptote. The shift to the x was back 1. So that means my asymptote, which used to be at x equals 0, needs to be back 1 at x equals negative 1. And you always are going to want to draw the asymptote into your graph. So let's take a look. We have to go up to 15. So I'm going to put my graph way over here. But my asymptote has to be negative 1. So here we go. Let's do this. Here's my y-axis. Over here is my x-axis. Okay. Now, I know the asymptote has to be at x equals negative 1, so I'm going to put that in first. Right? So that's my asymptote. It's a dashed red line that goes down through negative 1. It's a vertical line. Now I'm going to plot my points. Let's see, 0, negative 2. Here. 15, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's 15. So 15, 0. And where's this one? Negative 15 over 16, negative 4. Now, negative 15 over 16 is almost negative 1. So we're almost at negative 1. We're going to be down here at negative 4. So the picture is going to asymptote here and go through that. Voila. All right. So let's try these guys now. Okay. We want to sketch negative log base 3 x minus 4. So that's q of x equals negative log base 3 x minus 4. Now this says shifting again. So anytime it is shifting, I'm saying to myself, what would the parent function be? The parent would be y equals everything, get rid of all the extras. So I would get rid of the negative and the minus 4. So the parent would be y equals basic log base 3x. So I'm going to make an xy chart now for the parent. So xy, right? Oh, first I got to bend it. So it's 3 to the y equals x. Right? So I'm going to do negative 2, 0, 2. Okay. So 3 to the negative 2 would be 1/9. 3 to the 0 is 1. 3 squared is 9. And the asymptote for the original, the parent function, is x equals 0. So this is something, anytime I graph logs, I always do this. I make the parent. Now I'm going to do the equation they want us to do, which is y equals negative 3 x minus 4. All right. New xy chart. Now, a negative means there's going to be a reflection, either a reflection over the x-axis or a reflection over the y-axis. Now notice where this negative is. It's hanging out in front. That means you want to negate the y values. Right? If I wanted to negate the x's, the negative would have been in the parenthesis with the x. So since the negative's out in front, right, we're going to negate all the y's. We're going to do a reflection over the x-axis. So you're going to negate all of the y's with the negative out in front. Then I'm going to go to the x's and add on 4. So this will be 4 and 1/9. Right? This will be 5, and then add on 4 to that, will be 13. Okay? So this is what we're going to graph now, but next I want to get the new asymptote, then I can jump into it. Now again, the old asymptote is x equals 0. Did we do anything to the x? Yes, we did. We added on 4, so we're going to add on 4 and create a new asymptote there. All right, so this is what we want to graph. I'm going to set up my axes here. Okay, this is x, this is y. I'll just stab myself with a pen. Right, so there's my x and y axis. Now, always draw mass. All right, now I'm going to plot my points. 4 and 1/9, I'm going to be at 2. At 5, I'm going to be at 0. And at 13, 5, 6, 7, 8, 9, 10, 11, 12, here's 13. I'm going to be down at negative 1 and 2. And there we go. Now, because there was a negation out in front, that means it's going to be a reflection over the x-axis. Normally this graph would have looked like this, but the negative out in front flips it over. And there you go. Okay, now, and notice when I did the work here, before we do the next one, I always work from left to right, like I'm reading a book. I do that first, then I do that, then I would do whatever's next. So take a second. I'm going to read you what the equation is, then I'm going to ask you to pause me and see if you can get it. So it's d of x equals negative log base 2 x plus 1 plus 5. All right, so pause me, and let's see how it turns out. Okay, so I hope you pause me. What I'm going to do now is come up with my parent. Right? The parent function for this is, if I strip away all the extras, is going to be y equals log base 2x. That would be the parent function. And we're going to do more with this parent function idea next time. So now, if I bend it, it's 2 to the y equals x. All right, so x, y, negative 2, 0, 2. And again, I'm putting it down the y column because that's the exponent. 2 to the negative 2 is 4. 0 is 1. And 2 squared is 4. Okay, now the asymptote for a basic log graph is always x equals 0. All right, so now I'm going to do d of x, which is equal to negative log base 2 x plus 1 plus 5. All right, so, and all this guy is, it's shifting this guy around. So the negative out in front means we're negating the y's. So that becomes 2, 0, 2. Oh, negative 2. 2, 0, negative 2. Then we have x plus 1. All right, that means I'm subtracting 1 from each of these. So 1/4 minus 1 is negative 3/4. This would be 0 and 3. Now, this one has one more step. Check it out, plus 5. That means we're going up 5, so we're going to change these, go to the y values, and we're going to add 5 onto each of these. That becomes 7, 5, and 3. All right, and this is what we're now going to graph. So, well, actually, let's get the new asymptote. New asymptote. Now, x equals 0. What did we do to the x's? We subtracted 1 from the x's. So the new asymptote is x equals negative 1. Okay. I'm setting up my x and y axis here. X, y. My asymptote is at negative 1. So right here at negative 1, drawing in my asymptote. All right, now we're going to graph. At negative 3/4, so really close to negative 1, I'm up at 7. 1, 2, 3, 4, 5, 6. So here's 7 right there. At 0, 1, 2, 3, 4, I'm at 5. And at 3, 1, 2, 3, I'm at 3. So that means this would be hugging the asymptote and heading off in that direction. And that's the graph. All right. So I'm not giving you guys any of this particular homework to do tonight. So you're not going to have any assignments to submit for once. What I do want you to do is start to flip through your review packets. I gave you a bunch of them, 6 of them for the final. These questions do start to pop up in there. There should be a bunch more now based on the topics we've done the last couple days. You should be able to do more questions in those packets. All right.